Okay, so in this video, we're going to be talking about how to calculate the center of mass. And so we've kind of talked about center of mass before, but mostly we've been talking about the center of mass of uniform objects. And so today we're going to talk a little bit about how do you calculate the center of mass in situations where you don't necessarily have a uniform mass distribution. And so if you have a rigid object, then one of the benefits of the center of mass is that you can always assume, you can always treat the force of gravity as though it acts through that center of mass. And so, for example, in the past when we did calculations and we're drawing free body diagrams, we always put the force of gravity for an object through the center of mass. And so being able to calculate where the center of mass is located is helpful for that reason. Okay, and so the equation to calculate center of mass is on the screen, but I will rewrite it in a slightly different way. The equation you see where it says CG, that's center of gravity. That's the same thing for the purpose of this video. And so in the equation, XCM represents the X position, typically in meters, of the center of mass. Okay, and the equation, we have the sum of MI times XI divided by the sum of mi. And basically, ignore my ugly looking sigmas, but basically what equation is saying is on the bottom, this basically just says add up all the masses. Okay, so however many masses you have in the problem, add all those masses up. Okay, now for something like a meter stick that's made up of many different smaller masses, that's typically some place we would use calculus to do that adding up. And the problems we're going to be doing, we have only a few discrete masses that we're going to be adding up. Okay, so on the bottom of the equation, we're basically adding up all the masses, and so this would be like the total mass we have. Okay, in the top, when we see mi times xi, this basically says for each mass, multiply, and we're going to multiply the mass element times xi, where xi represents the distance from the origin that mass element is. Okay, and so on the top, we're basically adding up however many terms we have based off of how many masses we have in the problem. And so, for example, if we want to find the center of mass of like 3 bowling balls, we would be adding up 3 numbers on the top and 3 numbers on the bottom. Okay, on the top, each thing we would be adding, we would basically be multiplying that individual mass multiplied by the distance from the origin. Okay, and when we use this equation, the final result, remember XCM represents the position of the center of mass relative to the origin. Okay, and so we're going to do 2 quick examples just so you see how the calculations work. Okay, and so pause it here if you need to finish writing this down, and then we'll go to the next slide. Okay, this is the next slide of the notes. Like I said on the previous slide, if you have an object that is symmetrical, an object that is uniform mass density, the center of mass is going to be at the center of the object, the physical center of the object. Okay, and so what we're going to do now is we're going to use the equation we just saw to calculate the location of the center of mass if you don't have that type of object. Okay, what you see here is basically a picture showing you how the equation works. And so in this picture, we have 2 objects. And so the calculation to find the XCM, the position of the center of mass, would be m1x1 plus m2x2 divided by m1 plus m2. Okay, so again, notice on the bottom of the equation, we have the total combined mass. And then we're basically taking each mass individually and multiplying by how far that individual mass is from the origin. Okay, and so in this picture, the origin would basically be like this line over here. X1 represents the distance from the origin that mass 1 is, and X2 represents the distance that mass 2 is from the origin, and XCM is basically telling you what is the X position of the center of mass. Okay, so in this situation, the center of mass is basically right here along this line. Okay, and so let's do some examples really quickly. Okay, so in this example, it says 3 people are standing on the sidewalk as shown. Determine the coordinate of the center of mass for the three people, assuming x equals 0 is where the 70 kilogram person is standing. Okay, so in this situation, we're told where the origin is. Okay, and so the origin is going to be right here. Okay, so this is x equals 0. Now, I will tell you that no matter where you put the origin, it does not change where the actual center of mass is. It just kind of shifts around based off of the coordinate system you choose. But in this situation, we're told to assume x equals 0 is where the 70 kilogram person is standing. Okay, so I'm going to use the equation xcm is equal to the sum of mi xi divided by the sum of mi. And in this case, I goes from 1 to 3 because we have three different masses. Okay, and so I'm going to plug in. On the top, I have mass 1, which is 70, times x1, which is 0. Remember, x represents how far you are from the origin, but in this case, the origin is right here where this person is standing. Okay, so that's why we just have 0. Then I'm going to add, remember sigma represents addition. I'm going to add m2 times x2. So here m2 is 60, and I'm going to multiply that by x2, which in this case is how far this person is from the origin, which is 2 meters. Okay, and then I'm going to add one more term. I have m3 times x3. M3 is going to be mass 3, which is 82 kilograms, and X3 represents how far from the origin this third mass is, which in this case, they are 2 and then 4 meters from the origin, so that is going to be a total of 6. Okay, so I have three terms being added together. On the bottom, I have the sum of mi, which basically means, again, add up all the masses. And so that's going to be divided by 70 plus 60 plus 82. Okay, and so in my calculator, I'm going to do the top number first, and then I'm going to divide by the bottom number. Okay, so 70 times 0 is 0. I have 60 times 2 plus 82 times 6, and then I'm going to divide that by 70 plus 60 plus 82, and that gives me XCM is 2.9 meters. Okay, and so the answer to the question, XCM, would be equal to 2.9 meters. Meaning if you were to consider all three of these people and treat them as one big object, the force of gravity for that combined mass would act through the center of mass, which would be located at 2.9 meters, which if this is 2 meters, then 2.9 meters is probably, let's see, probably like here somewhere, I guess. Okay, and so that's where XCM would be located. Okay, so that is how you do a simple one-dimensional calculation for center of mass. Okay, so pause it there if you need to finish looking at that. Okay, so now let's go to the next slide. Okay, so let's take a look at this next question. So this question is one of your quest homework questions. And the question says, a square plate is produced by welding together four smaller square plates, each of side A. The weight of each of the four plates is shown in the figure. And the question asks you to find the x-coordinate of the center of gravity as a multiple of A. Okay, so I'm going to open up a new sheet for this, just so I have more room to write. Okay, so if you want to take a picture of this image or pull up on your computer, do so now. Okay, so let's do the calculation for the x-coordinate of the center of gravity as a multiple of A. Okay, so first of all, we have here four different masses. Okay, and so I'm going to write down the four different masses. These are actually not masses, these are actually weights. Okay, so we have 50 newtons, 90 newtons, 40 newtons, and 90 newtons again. Okay, so let's say we have four different weights. I'm going to say W1, W2, W3, and W4. Okay, I call them W just because I don't want to write out FG just to save on space. So W representing the weight. Okay, and so let's say W1 is 50 newtons, W2 is 90 newtons. So we have 50, we have 90, W3 is 40 newtons, and W4 is 90 newtons. Okay, now XCM is going to be the sum of MI XI divided by the sum of the masses. Now, we don't actually have the masses. What we have is the force of gravity, but the force of gravity is proportional to the masses because the force of gravity, the weight, is just m times g. And so even though, technically speaking, we should be doing this calculation with mass, we're still going to get the same answer if we use the force of gravity because at the end of the day, the only difference between mass and weight is the mass is multiplied by 9.81 to get the weight, and the 9.81 would cancel out if we plugged it into the top and bottom of the equation. Okay, and so even though technically speaking I should be using mass for this calculation, it's not going to change the final answer if I just keep this as weight. Okay, and so first of all, let's take a look at the picture again and figure out where these weights are located. So remember, xi represents the x distance from the origin to each of the individual masses. Okay, so for example, right here, okay, this is the x coordinate for this mass, okay, that's in the center of the plate. Okay, so what is the x coordinate here? Well, if this whole side is A and we go halfway through here, then this x coordinate would be A divided by 2, because if it's a square plate, the the force of gravity is going to act through the center of that plate. And so the x value that we're going to plug in for xi is going to be A divided by 2 for these two plates on the left. Okay, and so I'm going to go back to the slide right here. And so the first thing I'm going to do, I'm plugging into the top. I have mi times xi, so I'm going to start with the top left plate. That's going to be 50 times A divided by 2. Okay, so 50, again, is not actually my mass, but it's proportional to the mass, so it still works. And then xi is how far from the origin in the x direction that object is, which in this case is A divided by 2. Then I'm going to do plus 90 times A divided by 2. Okay, and so what I have so far, I have two terms written down. Okay, so what I have so far is I've basically done the calculation for this mass on the top left, and then the one for the bottom left. Okay, so what about the 40 newtons and the 90 newtons? Well, those are at a distance of 3a over 2 from the origin. And so now I'm going to do 40 times 3a divided by 2 plus 90 times 3a divided by 2. And if you don't know why it's 3a over 2, go back and look at the picture. Measure from the origin in the x direction to the center of each of those plates. Okay, each plate has a length of a. Okay, so if you go to the middle of the plates on the right, that distance in the x direction would be 1.5a, which is 3a divided by 2. Okay, so I have my 4 terms on the top, and then I need to divide by the combined mass, or in this case, the combined weight, which would be 50 plus 90 plus 40 plus 90. And I type all of this into my calculator. And notice what you get is you don't know what A is, but the actual question asks you to answer the question in terms of A. Okay, and so the fact that the A does not cancel out is fine. Okay, so what I'm going to do now is I'm going to type all of this into my calculator, kind of ignoring the A's for right now. Okay, so I have 40 times 1.5 plus 90 times 1.5, and then I'm going to divide by the bottom, which is 50 plus 90 plus 40 plus 90, and I get a answer of 0.98a. Okay, and this is going to be xcm. Okay, 0.98a. Okay, and so the question in quest asks you to answer in terms of a and multiples of a, and so this is a multiple of a. Okay, so in other words, the center of mass for these 4 plates is somewhere around 0.98a. Okay, now the second question, which I'm not going to do the second question, but the second question is the exact same calculation. The only difference for part two is instead of the y coordinate of the center of mass, the question is asking about the, instead of the x coordinate of the center of mass, it's asking about the y coordinate. And so the way you do the calculation is the exact same as what you see on your screen. The only difference is all of the x's are replaced with y's. Okay, so in other words, you would have ycm equals, okay, this equation right here, except it would be the sum of mi times yi divided by the combined mass. Okay, and so you would basically just do the exact same calculations, but you would do everything for the y direction instead of the x direction. Okay, and so you should be able to now answer that question in Quest. Those two questions in Quest actually, and you should be able to calculate the center of mass for the for discrete objects. Okay, so as always, please let me know if you have any questions, and I will see you in the next video.